It should be the same way to set up and solve. And then number 2 I'll do with you. That's the other type we have. Okay, so if we have our two lengths, our two side lengths congruent, then that makes this line a perpendicular bisector. So I add in my other lines and my right angle. So this is the converse, where we read it backwards. Same thing that we do here, you're just going to be setting all these equations equal to each other. So I'll let you set this one up and try this one. We're just going to be setting these two equations equal to each other, and then you can pause the video here and solve, and then find the answer. Also, sorry that my voice is a little weird. I'm sick, so I'm a little nasally, so I apologize. Okay, so you should have gotten x equals 2 on number 2. If you have questions about that, maybe ask a partner if you didn't get x equals 2. And that is going to be the same as the rest of these, so go ahead and pause the video here and try these, all these examples on your own. And also notice we're not just finding x in these other examples, we're now finding EG, so we'll have to plug back in. So we'll have to plug in x for all the rest of these to find the corresponding side that they would like. So go ahead and try these before we move on to angle bisectors. You can pause the video here. Okay, so moving on to angle bisectors, we should know that this is when an angle is split in half or into two congruent angles. So I can tell that this is an angle bisector here because it is a ray. Okay, angle bisectors will always be a ray because that is what angles are made up of. So angle bisectors are rays. You can make that note up top, which means there's one endpoint at A and then it continues on in one direction. So I know that's my angle bisector because of these congruent marks. Okay, so I have two congruent angles there, which tells me that that has been split in half. So if I have an angle bisector, so it's telling me here if AD bisects my big angle BAC, then I have two perpendicular and I have two perpendicular segments there. Then I know that these two segments are going to be the same. They're going to be that same distance from the sides of the angle. So not these long sides of the actual angle, but it's going to be that same distance away from the sides. So a little different than perpendicular bisector theorem, but still the same concept. We're just going to be setting things equal. So if I name those two segments, if I just name this little piece, it's from B to D. So BD is congruent or equal to CD. Then I change that color. BD is equal to CD. Same thing goes here. If I have these equal parts down here, then I can say that this is an angle bisector. So therefore, we can mark my angles as congruent. And we can say that AD is an angle bisector. But in order to name those two angles, remember, it's just like we draw it. So CAD, a little dyslexic there. CAD is going to be equal to angle BAD. Remember, we want the vertex A in the middle there. Okay, so that again tells me that that point is on the angle bisector if we read the actual theorem here. So again, converse just puts that theorem in reverse. It just switches the order. So let's go ahead and try some examples here. First thing I want to look for, we want to check for congruent arcs, which tells me I have congruent angles. And then also our right angles down at the bottom, but really as long as we have congruent arcs there, that's going to tell me that that's an angle bisector. But I'll also put my right angle boxes. So we want to check for that first. Once we see that, then I can say that these are the same distance away from my angle bisector. So we can go ahead and set these equal and solve. So pause the video here and see if you can set this one up. Okay, that should have been your setup there. We're just putting an equal sign in between, and go ahead and solve for x. Okay, so I put all the steps of the equation there, and you should have gotten x equals 7. So you can double check there if you didn't get that. And then our other type is going to be when we're setting our angles equal to each other. So once we see that this is my angle bisector because of these congruent marks down here, I know that these are going to be congruent angles. And we can kind of see that that's splitting them there. So it's another kind of indication that that's an angle bisector. So same thing, if they're congruent, that means what? That means we're going to set them equal. So we're going to do 5x, minus 11 is equal to 8x minus 41. And pause the video and go ahead and solve here. And go ahead and solve for the rest, noticing what it's asking for, whether it's an angle or a side. We can tell that by the symbol. So when we see an angle symbol, I know it's going to be plugging back into an angle. When it's just 2 points, it's going to be finding a side length. So once you finish this, we're going to be done with notes. You can double check with the sub. She has an answer key to make sure we're on the right page, and then you can go ahead and start your prep work. And have a wonderful weekend.